Good morning, everybody. We're going to test this DC injection brake. Here's the front cover right here. It's made by Horstman. Here's the model number down here, 16-083-98800. Turn on the 220 volts line voltage. Turn on the 110. Now this contactor right here applies the line voltage to the motor. This contactor over here applies the DC voltage to the motor. And you can't turn them on both at the same time. You'll be putting AC and DC together. At the end of the video, I'll show you the hookups here, and we'll go into a little bit of theory. Let's test it. This contactor is closed, and we're running the motor. I'm going to turn off this contactor and turn on this one. There we go. Turn off the second contactor, the DC contactor, turn on the line voltage to the motor with this contactor. Turn off that contactor, turn on this contactor. Isn't that amazing? Now don't forget to turn this second contactor off when you turn this contactor back on. That is amazing. Alright, I'm going to turn on this contactor and the motor will start. This red LED right here, this is the motor running LED. These two green LEDs up here are brake current 1 and brake current 2. This brake here can stop two motors. Right now we're hooked up to the number 1 SCR side. There's a dual SCR in here. In a moment we can go check the number 2 SCR side and see if it works. Okay, let's open up this contactor. The two green LEDs turned on and the red LED turned off. Let's try it again. There we go. I didn't close this contactor quick enough the last time. One more time. Isn't that amazing? Now these potentiometers right here, these first two, this one here on the top side, that's for the second DC injection brake output. It's torque. This one's for the first DC injection output torque. This one sets the time. I'll adjust that real quick and you'll see that the time the DC is applied to the motor increases when I increase that pot right there. You can also adjust how hard it torques, how hard it stops. Back the time off a little bit more. You see that? It stopped faster. We'll set those back midway. Now let me power everything down and we're going to move to the DC number 2 output. The 220 is off. The 120 is off. Let's move over to number 2. Remove this wire here. There we go. That's number 2 minus. And we move from number 1 plus to number 2 plus. I'm bumping into the camera. Everything's too close. Now let's see how this side does. There's the 120 applied. Here's the 220. Close this contactor. There goes the motor. It's working too. Let's turn that contactor off right there. Let's run the motor again. Open this contactor up. Oh yeah. Alright folks, when I get home, we'll talk about these hookups. We'll see you when we get there. Now we'll take a look at the DC waveforms that are being injected into that motor. Now here the motor's running. Now we're braking. Let's try it again. Close the contactor to apply 220 volts AC 3-phase to the motor. We're going to open up that contactor. Now we're going to close the DC injection brake contactor. Open up that contactor. Let's run the motor again. There's some good waveforms right there. Evening all. Here are the hookups for the Horstman DC brake. Now up here we have to apply 120 volts AC single phase to pins 1 and 2 of the K1 terminal board connector. Now that's selectable. I'll show you a picture here in a little bit of what I'm talking about. You can either have 120 volts AC or two 20 volts AC input to the power supply of that Horstman DC injection brake. Now down here we have an external power supply of plus 24 volts DC, and the polarity doesn't matter because it goes into a bridge rectifier that corrects the polarity of this input. That goes into K2 pin 3 and 4. Now notice here's an auxiliary contact. When that auxiliary contact of CR1 closes and the motor is running because these three contacts have closed and applied 220 volts AC 3-phase to the motor, the red LED, the running LED, the motor running LED illuminates. Now, when we also have that same 220 volts AC from L1 to L2 comes down to terminal connections on the front of the Horstman DC injection brake labeled L1 and L2. As in the video, you saw me open up that first contactor and the motor started to coast, and this auxiliary contact, when it opened up and removed that 24 volt DC input, it told the drive to start applying a DC voltage out on these terminals right here. There's two outputs, one plus and one minus to one motor, and 2 plus and 2 minus to the second motor. The DC is applied to this terminal. These are on the front of the Horstman DC injection brake also. To apply that DC, we have to close this second contactor. And you saw me close that, and the DC was applied to the motor and stopped that motor. Isn't that amazing? I like that. Okay, let me put the picture up of the terminal board up here, and you'll see how to select either 110 volt or 220 volt on K1 pins 1 and 2. There's a selector card right here, and the DC injection brake that came into the shop was set to 110 volts. So I applied 110 volts on K1 pins 1 and 2. If I pulled this card out and flipped it around and put it back in, it would say 220 volts. And I would have to apply 220 volts to K1 terminals 1 and 2, pins 1 and 2. Now here on K2, 3 and 4, that's where the 24 volts comes in and tells the DC injection brake that the motor is running, or when that input is opened up and no 24 volts applied, the DC injection brake starts to apply, I don't know if you can see it down here, starts to apply the DC to stop that motor. Now this relay right here, whenever the motor is running, this relay is de-energized. The contacts are down here, and I'm not quite sure the output of those contacts. But when I stop the motor, this relay closes. That indicates to me, and I don't have the manual on this Horstman DC injection brake, but that indicates to me that possibly I could use that relay to close the DC injection brake contactor. This contactor right here. So if I could use the contacts of that relay here, that would eliminate me having to open up or close this contactor right here. you would still have to have a contactor. This relay right here is too small. It could not carry the currents required to stop that motor. It would burn up these contacts. What I'm talking about is I could use the outputs of this relay right here to energize and de-energize this main contactor right here, the coil. I'll have to try that next time. Or y'all could try that. You maybe could use that relay to close and open this relay right here, this contactor. We'll try it in the future. If not, have you 2 contactors and 2 power strips, and turn this power strip on, turn this power strip off, turn this power strip on to apply the DC, and then turn the power strip off, energizing and de-energizing these relay coils. That's nice. A lot of wires, but once you get it hooked up, not hard to test. Alright all, thank you very much for stopping by and seeing what we're working on next. Y'all have a good night, and we'll see you next time.